and girls, today we are going to continue our lesson and review on matter. We're going to move into solutions, salt and water. We've done this before. We tried to make lemonade on Friday. So what statement describes a solution of salt and water? Well, we know that when I put salt into water, it's dissolving. And if it is dissolving, that means that the salt particles are spread evenly throughout the water. Water and salt is a solution. So the salt particles, they are spread evenly throughout the water. We know that it couldn't, if we even look and say that we didn't even know that that's what it was, right? I know that it can't be A because it's not floating. I also know that it can't be B because I'm not combining. I'm not forming a new substance. And I also know that it can't be C because they're not clumped together. So by process of elimination, even if I don't know that the particles are spread evenly, I know that A, B, and C are completely wrong, so D would be my only choice. But again, we do know that because this is a solution, the salt is dissolving. That means that those particles are spreading evenly throughout the water. Moving on to question 2. Why does wearing thick clothes help you keep you warm on a warm day? Guys, think about conductors and think about insulators. Conductors is the heat is moving through it, right? Just like the electric conductors, the electricity is moving through it. So I know that I'm not wanting a conductor. Don't want a conductor, okay? And I also know that my clothes don't generate heat. They're not getting heat when I'm moving inside of it. They don't like all of a sudden decide that because I'm moving that they're going to create some heat. That's what generate means, is that they're going to create. They're not going to create heat. Okay? I do know that my clothes are thermal insulators. And because they're thermal insulators, they do trap heat. And because they trap heat, they're trapping heat near my body. My body heat is being trapped by that thermal insulator to keep me warm. It obviously cannot be D because my energy is not being, that thermal energy isn't being gathered from the environment around me, right? It's my body heat is being trapped by the clothes as a thermal insulator. So C is my correct answer. If I'm looking at question 3, how Sharon, she wants to separate a mixture of 2 materials. So she's taking this mixture, she's separating it. What criteria means, criteria is rules, make a magnet useful to use. So this fancy words are basically what rules do I need to use a magnet? Why would I use a magnet? Okay? And again, I'm separating. So that means both materials cannot be magnetic because I'm separating. So that's just a silly answer. Okay? However, when only one of the materials is magnetic, my magnet is going to attract it and it's going to leave all the other stuff behind. So one of my rules is that only one of the materials is magnetic. One of my other rules is that the magnet needs to be strong enough to lift that magnetic material. I can't lift it if my magnet is weak and not strong enough. Okay? I don't care about D because Obviously, even the strongest magnet is not going to lift that non-magnetic material. So that's a silly answer. And E, my magnet's not going to work, really, if I have only a north pole or a south pole, right? Because every magnet has a north pole and a south pole. Every single magnet in the world. It wouldn't be a magnet if it didn't. So those are silly answers. So again, to separate this mixture, I have to be able to have only one of the materials it can be magnetic so that I can separate them out. And my magnet needs to be strong enough to lift that magnetic material. All right. So let's move on to question 4. Okay. So Helene measures the mass. Remember, mass is my weight. So I'm weighing my flower pot before I fill it with soil. And then I'm going to weigh it again after I fill it with soil. So now I have to fill in this missing line. Okay? So I know that when I fill it with soil, when it's at its heaviest, I have 110 grams. Okay? However, without dirt, it's 85 grams. This is just like the cars where we were weighing them on the scales and trying to find the difference. And find the difference means we have to subtract. So 0 cannot take away 5. So I make this a 10. I borrow from this 1 and make it a 0. 10 minus 5 is 5. Again, 0 can't take away 8, so I have to borrow next door, making this a 0 and making this a 10. 10 minus 8 is 2. So my difference between 110 grams and the 85 grams is 25 grams. Again, this question is just like the one that we did on our test that had the balance beams of the cars and trying to find the difference in grams between one set versus the other set of cars. If you look now at question 5, the question states, when placed in water, a toy car and a rubber duck behave in different ways. So they behave in different ways, funny way of saying they do different things. Okay? So I'm going to enter these words to complete the explanation. All right? So I look at the toy car. It's all the way at the bottom. So I know that the toy car, if it's all the way to the bottom, that means it sinks. So the toy car sinks because if it sinks, that means it is more dense than water. The rubber duck floats. It's up at the top because it is less dense than water. The very important thing to understand about this, again, you see a fish tank, you see anything about water, you're going to talk about two different things. You're going to talk about either density or you're going to be talking about solubility. So with density, the less dense means it's up on the top. The more dense it is, it's going to sink. It's going to be on the bottom. So because my toy car is on the bottom, it is more dense than the water. Because my rubber duck is floating up there, that means it is less dense than the water. Number 6 is talking all about the properties of copper. Okay? So I know that here's my properties. A, it's not soluble in water, which means it's not going to dissolve in water. B, it's not magnetic. We know that those two are actually true because it's not dissolving in water and my magnet's not going to help it. We know that it is an excellent thermal conductor, which is heat, and it is also an excellent electrical conductor, which is has to do with our electricity. E says that it is flexible, so bendable enough to be pulled into a wire. which we also know is true because our wires that we saw a couple of weeks ago had that copper underneath the plastic. Okay. The question is, which of these properties of copper make it useful in appliances? So why do we need copper in lamps? Why do we need them in cell phones and computers? And again, you want to select 2 correct answers. Okay? Let's look at A. Even though we know that copper is not soluble in water, it's not going to dissolve in water. That property tells me nothing in terms of lamps and cell phones and computers. I don't need that. So that's just a silly answer. We know that copper is not magnetic. But again, that property does not explain why I need it in lamps, cell phones, and computers. The thermal conductivity of copper makes it useful when I'm cooking, but it doesn't necessarily make it useful when I'm talking about lamps, cell phones, and computers. My electric appliances don't really care about thermal conductivity. Lamps, cell phones, and computers are all electrical appliances. So of course, I want to know that my copper is an excellent electrical conductor. I also really want to know that it is flexible enough to be pulled into a wire, because I need that for my electricity. I need that in order for it to be an electrical conductor. I need those things. For my lamps, my cell phones, my computers, anything electrical, I need to know that it's going to be a conductor, and I need to know that it's going to be flexible and I can put it into a wire. Moving on to number 7, Sheena is investigating the properties of magnets. How can she demonstrate? How can she show that a magnet can repel, that a magnet can push away, or cause this pushing force? So how can I show that when I use a magnet that the non-magnetic things are not going to stick up to my magnet and be attracted to it, but yet it's going to push away and repel those? Okay. Letter A says that the bringing the like poles of 2 magnets close together. That is our answer, because the like poles of 2 magnets, okay, if I put 2 magnets together, the plus side and the plus side together, they're going to repel each other. They're going to push away from each other. All right? If I put the opposite together, they're going to stick. They're going to attract each other. So, the way to demonstrate how to repel and how to push is to put those 2 like poles, the side A and side A together, or the plus side and the plus side together, to show that they are then going to push away and separate. The last question, boys and girls, is a 2-parter, and this is one where, once again, I'm going to go over part B, and then you're going to, after this video, rewrite and make sure that your SCR is written correctly, the way so that you would get full credit. So, question 8, first part is that at the hardware store, a customer buys a can filled with liquid paint thinner. Okay? I'm going to do a test. What test would provide the most useful evidence that the paint thinner is a liquid, not a solid or a gas? We did a very similar question to this yesterday when we talked about why is sand a solid and not a liquid. So now I want to know why this is a liquid. Why is paint thinner a liquid but not a solid or a gas? So I'm going to use the same logic that I used yesterday to today's question. Okay? So A is saying, hey, let's just measure the mass and the volume. And that's going to tell us its density. Okay? Well, a solid, a liquid, or a gas, all three of those can be described by mass, volume, and density. I want to focus on why and how do I know that it's just a liquid. But if I can do this, if I can measure the mass and volume and density of a solid, a liquid, and a gas, this one's not going to help me. Okay? B says, pour the paint thinner into this larger container and watch it. You're going to observe it taking on a new, larger volume and a larger shape. Well, a gas is the one that's going to take on the shape and the size of the container, not a liquid. Okay? So if we're talking about gas, that would be a great answer for gas, not liquid. C says that we're going to pour the paint thinner into a new container, and we're going to observe it, we're going to watch it, and it's going to take on a new shape, but the volume stays the same. So the shape changes, but the volume, the amount of space that it takes up, stays the same. So a liquid, like we're moving our lemonade from cup to cup, is going to always take on the shape of whatever container it is, but the size does not change. When I have 1 cup of water, no matter where I place it, it's still 1 cup of water. So our answer is C. Because if we look at D, if I want to mix the paint thinner with blue paint and then I'm going to figure out if it's a solution, well, I can create a solution out of solids, liquids, and gases. So the only one that really applies to liquid is that the fact that the volume stays the same, the size stays the same no matter what container I put it in. The very last question that I really want to work on, and this is one of those paragraphs that you need to be writing 3 to 5 sentences on in order to get full credit. And you need to be able to answer all parts of the question. So Natalie argues that a sponge is not a solid because it can be squeezed easily. So she demonstrates that a sponge can be squeezed into several small places. And each of those spaces are a different shape and a different size. Do you agree with Natalie that a sponge is not a solid? Boys and girls, in order to get full credit, your answer should sound something along the lines of, I disagree with Natalie. So you're restating it, I disagree with Natalie. A sponge is a flexible solid. So a sponge is a sponge is a flexible solid because it holds air in the spaces that are inside of it. Squeezing the sponge removes the air and allows the sponge to take on a smaller size. Boys and girls, you are answering the question. You're saying yes or no, and then you're explaining your reasons why. I want you to take some time after this video to go back to part B, and I want you to rewrite your constructed response to make it so that you would get full credit for this question. Thank you.